Good day, everyone, wherever you are, and welcome to yet another exciting episode of AI Climbing with Sheikh. As we together navigate our journey towards the complex but obviously exciting journey into the real AI. Yeah, let's see what I have today, and I am publishing this after several weeks, and the reason being I had been trying to simplify some of those very witty things. And the today's topic, as you can see, is resolving human AI challenges with agentic AI. It's a big line and perhaps very complex thing hidden inside. I have carefully selected this title of human AI because, as you know, right, like with LLMs and some of those technologies, obviously, what we are trying to achieve is more intelligent, number one, and then more communicative and more pervasive AI, right? And everything is moving towards a more like a tool which can act like a human that actually becomes a brain over time. And recently, we are hearing a lot of things about the agents, agentic AI. We have been working on few systems that can really deliver and deploy and show some power out of it. So, without much delay, let's continue. As you can see, right, I will be really starting off with some high level definition and how actually it unfolds. As we all know, we understand now AI with the concept of the LLM and how this big LLM you can query anything and it will output whether it is a picture or a voice or whatsoever. And where we want to go is more like a complete orchestration mechanism, right? Where ultimately there are different models and different applications who are communicating with each other. And as you know, right, that outcome actually becomes the definition of an agent. And when you see this question mark as a process, actually it becomes many things in itself, some MLOps platform capabilities. Similarly, if you have heard about MCP, which is Model Context Protocol, and I shall be sharing some cool things forward, but I hope you get the idea. The outcome is the agent, and then the process is something like MCP or agent or an agentic AI. And that pretty much sets the boundaries between the two. And as we will continue, let's try to see something more. Again, highly encourage to go through the deck, and I will put it the link in the chat. And the whole idea is see some standard definition of the AI agent itself. And where I want to start is really about the three, key dimensions that you should know. So you just need to consider agent like a cycle or a closed loop, right? Where ultimately you will sense the environment, which is more on the behavior side. So it is not a fixed thing. It can take some inputs dynamically from the environment. Then naturally it can do some process and math functions and objective functions and take some achieve some output from the scenario, and then he can make a decisions like compare the real versus predictive, all those typical LLM stuff, right? Like process through which it will evaluate different options. And if you see it in a way, I really want you also take this great picture from NVIDIA, how they define it, right? And I really like it in a way because on the extreme left top, you will see a very simple chatic interface, which is an LLM, and then naturally you will see how this whole cycle work, right? So I show you the sensing of a environment and setting some boundaries, which is the planning phase, And then there is a lot of tools, not one tool, and that's the point I want to share with you. That's, remember that question mark I was showing? Actually, you can connect with the database, the application front ends, the semantic search, few models, few apps, and then you can reason it, right? And I will showing you a demo as we evolve, and I hope it will help you. And the cycle is the key, and the outcome is the agent, right? So that is all I want to tell you. And look, forget about lot of this marketing, and the people are talking, and the agentic AI memories, and agentic AI can do everything. We will really stab at it from stepwise. And in this episode, I just want to see an architecture side and a bigger picture, how it works and how it will not. And let's try to understand different domains of agentic AI. And as you can see, right, let's try to start from reactivity and proactivity side, right? Like, as you can see, right, both of those comes to the sensing of your environment, right? One is obviously once the issue happened, other is the predictive or a more early detection side of it. And as we move naturally, there is a learning ability, a human AI, which is collaboration with humans, and how you will adopt and refine actions and run this intelligence loop. And then the process side, which is more like the tooling, mobility, and autonomy, how you will actually connect and run the task across different tools and then do it in an automated way. So automation of task is naturally important over here. And you remember, autonomy also means a decision making between different options. So the cycle is very important that you view it in a way. And now let us see a difference between a LLM way of the world and the agentic view of the world, right? And you can see on the left side, I try to a sort of map the agent side of the world, and the right side is the classic LLM. So you can see, right, agent is a autonomous system, real time perception of the environment, versus LLM, where obviously there is a big guy, big fat brain, and you are querying from that. And then agent can take goals, whereas the LLM you consider more like a fancy NLP. And agent is quite autonomous, right, in a dynamic environment. LLM is a sort of reactive. You can still do prompts, a lot of prompts to to contextualize it, but again, that's a reactive. That's what we actually call reactive. Actually, the agent will give you not just the output but also the reasoning, which is planning how they arrive at the decisions, some mass behind it. Whereas LLM, bits of it, but then it is more just good in doing some NLP and probabilities, not some detailed task planning and execution. Learning ability quite dynamic, learn like humans, reinforcement, real time updates, sensing the environment. Whereas the learning ability of LLM largely is limited to some classic examples of SFT, supervised fine tuning, and others. And then, in terms of modality, you can expect the agents, they are multimodal, sense everything. LLMs can be multimodal, but then each of those multimodes act and stand out. And one classic example I want to give you, try to use some LLMs like the DALI and the Vertex, the thing is, if you ask him draw a picture, write a text, or perhaps do something else, it always misses. So picture is good, text is not good, text is good, picture is not good. So ultimately, you see that agent mechanism is a sort of lacking over here. And then again, in terms of memory, classically important and look like how the human brain works, right? Like agent must have a persistent memory, and this context should be programmable versus a fixed context. Google has done, a very large, 100K, 200K contacts versus chat gpt, who is I think quite limited, 10K or others. But the thing is, it's not just the memory size, it's also the contact. So the agents keep, and I will show you, some working thing I had, but for the time being, just focus on it. And then environment interaction, I showed you, that MCP thing. And like agent can work with this environment, sensor actuators, whereas all interface of LLM is obviously the NLP and how you actually feeds in, right? And naturally, it means the agent can self program, self adapt to the changing environment versus LLM require reprompting, retraining, supervised fine tuning, post tuning, right? And in terms of tools, as you can see, right, the agent sits at the right architecture point. You remember, I told you agent is the outcome, and then that question mark is the set of those tools and integration. So classically agent is falling into that mechanism, and whereas the LLM again, you need to put a top level wrapper, whether you call the lag chain or others, to make it work. And in terms of interactivity, and you can consider an agent, it can engage in multi-turn goal driven architecture, negotiation, scenario comparison. Whereas in terms of state awareness, LLM's capabilities are quite limited, right? And then again, agents are quite modular, whereas LLMs, like, this 400, 500 billion, 1 trillion para monolithic. So it's not modular in that way. And then the examples, right? I will give you some demo, but the thing is, all of the real human AI act is actually the agent domain, autonomous robots and virtual customer agents, which we are building, and AI code pilots. So these all outcomes are actually the outcomes of the agents, whereas naturally LLMs give you one fat brain, and I told you, you can ask him, and like your old granny, try to answer it, whether he knows or not. And the last piece is adaptability. So agents adopt to the real world feedback, whereas LLMs are quite limited in the adaptability unless fine tuned and you do it again and again, perhaps a rag way. It takes us to the communication thing, because as you know, right, for this to understand, you really need to understand how the human brain or functions to take a task and solve it, right? And as you can see, there is not just loop, there are a lot of loops from your childhood era to, to this age, and then the different loops talk to each other. Then there is a high level conscious. So ultimately, the point I want to tell you, there are many communication architectures, and there is an external world of the view, which is outside and sensing view, and then there is an inner. And then, each of these big loop can cause the other small loops, and some good or some bad. And that's pretty much the different architectures. And you really need to understand, to build the right agentic AI solutions, you must know how to connect and talk to different loops and use them in a meaningful way. And yeah, let's try to see some a real cool example of how these agents. And so the thing is, it's not something only like theory, but obviously there is a lot of real thing, especially the video games. Like I was just trying to, obviously my son play a lot of Roblox, and we are definitely into this, like how we can actually build some of our game, and with an AI thing, right? Yeah, so you see, right, like if you go and explore the environment and you see how this game works, so there is this guy and obstacles, and ultimately it needs to cross it, right? And you really need to, like, as you will play these games, and you will find that ultimately that's is showing a classic examples of the agents and obstacles and this. So there is a really cool video from this guy, and let me try to see if you can see it. And it's a bit
Me.
long, but let's
No.
just take a minute. I
No.
hope it will make
No.
sense.
No. Maybe a worthy challenge.
Today, I'm finally going to be pushing the RTX 4090 to its absolute limit. And I should have got this video out a while ago, but it took me an actual eternity to acquire a 4090, and then I kinda got distracted playing other games on said 4090. But that's in the past, and it is officially time to pit this thing to truly max out the 4090's potential, just like I did with the RTX 3090 and 3090 Ti. And let me tell you, I'm sure there's a decent chance you've already heard this, but the 4090 is an absolute monster. Like, compared to the previous few graphics cards I've had, which were already pretty amazing, this thing's just a complete beast. So it'll be pretty at it. And by the way, this was tech, so do keep that in mind. And again, so do I, so here we are. And anyway, I believe I've done enough explaining, and now it's time to see what the 4090 is truly capable of. So, yeah, and this is the one will install Sodium, which is about 2200 FPS. CPU usage is available, and I figure many of you would like to know how it runs on the.
All right, so I think that was, I think, the notion of what I wanted to show you over here, and I hope you are getting it right, like how a real example of agent works. So do check those details. And now let's try to put everything back. And actually, I want to talk about one of the agentic AI solution we are trying to build for custom service, to be quite focused on the enterprise and the networking space. And as you can see, we are actually trying to put this agentic AI with a typical RAG architecture, right? RAG, I hope you are aware that it's more about integrating your data into that big model and then contextualize. What good thing we are doing is we are going after the problems in the custom service agents, like curate the data with the right governance and trust and self-explainable AI, right? As you can see, right, that is actually the key part of the brain of our agent, how we can integrate smoothly with the live systems and then make this more explainable in the way. And so the key decision engine, what we will be doing here, it's really around explainability and proactive issue resolution. And the blue boxes, what you are seeing, are the classic, NLP and speech processing. And I hope you can find a lot of material on this. But what I really want to see, we are working on a demo which we will be publishing, right? Like how to ingest and build real time knowledge and automate knowledge based on real time learning from customer interactions. That's pretty much what we are targeting, and I hope it makes sense. But again, unless you don't see a running code, you will not believe. So I will come back with some things over here shortly. And so just trying to grab a picture of this architecture in a way, and then yep, that's, I think, pretty much all how this agentic AI is being applied in real. And that's pretty much all for this episode. And I want to just wrap up quickly with just two key points, right? First is agents are objectively the LLM orchestration with a brain. So you must apply the orchestration and automation thing into the house. And then the last piece which I really want to talk about is really about the real time sensing of the environment. So it's not static. You should be able to ingest data, tune it, feel it, and make decisions out of it. Again, trying to build something on the OpenShift AI and Real AI, something important. And yeah, we talk about as we move. And that's pretty much all. And if you like the channel and see some value, then don't forget to like and subscribe. You can scan the QR code or otherwise click these links. All of those material will be, published in the link we will add in the chat, and download it, use it, and try it. And for the next time, till the next time, thank you very much and goodbye. Enjoy the rest of your day.